Ms. Myers.
Let me inspire you.
This is about matter is everything around you. Atoms and compounds are all made of very small parts of matter. Those atoms go on to build the things you see and touch every day. Matter is defined as anything that has mass and takes up space. Matter has volume.
The atom. Nucleus contains protons and neutrons.
Neutrons are neutral, meaning they have no charge. Protons are positive, so they have a positive charge.
Electron cloud.
The electron cloud surrounds the nucleus. It houses the moving electrons on energy levels or shells. Electrons have a negative charge.
Atoms contain an equal amount of positive and negative charges, so the atom is neutral as a whole. The periodic table is made up of elements. You can see symbols, and on some of them you'll see names. It's arranged in columns and in rows, and each box has information for a particular element. Let's look at carbon as an example. The first thing you notice when looking at each box would be the symbols. C in this box is the element symbol for carbon. The whole number in each box is the atomic number for the element. The decimal number is the atomic mass for each element.
We can use the periodic table and the information on it to determine how many protons, neutrons, and electrons an element has.
Let's look back at the atomic number. This is used to determine the number of protons an element has. The number of protons is a unique property that identifies each element. If you notice, the periodic table is also arranged by atomic number in increasing order. I mentioned before that the atomic number is used to determine how many protons an element has, but it is also used to determine the number of electrons. So here, carbon's atomic number is 6. That tells me it has 6 protons and also 6 electrons.
The atomic mass is the number of protons plus the number of neutrons in an atom. It is always rounded when used for calculations.
The atomic mass consists of the number of protons an element has plus the number of neutrons an element has. We can use the atomic mass to determine the number of neutrons an element has. To calculate the number of neutrons, you take the atomic mass rounded minus the atomic number. So the atomic mass here for carbon is 12.01, which would round to 12. You'll subtract the atomic number, which is 6. 12 minus 6 is going to equal 6 neutrons. Recap. Each element box contains the atomic number, the symbol, sometimes it will show the name depending on the periodic table, and it also shows you the atomic mass. The atomic number is your number of electrons, and it's also the same thing as your number of protons. The atomic mass is written in atomic mass units. It consists of the number of protons plus the number of neutrons. To calculate the number of neutrons, you round the mass and subtract the atomic number, which would also be the same thing as rounding the mass and subtracting the number of protons. Fill in the following information on your atomic math page. You will need to use a periodic table to complete the following. So let's look at oxygen. In the blank, you'll write the name, oxygen, and then we're going to fill in the numbers underneath it. So 8, we learned, is the atomic number, but it is also your number of protons and your number of electrons. So you can go ahead and fill that in. To figure out the atomic mass, we're going to round it because it's going to be used in a second. So 15.999 rounds up to 16. And then last we have the number of neutrons. We'll use the atomic mass rounded minus the atomic number. So it's 16 minus 8 gives us 8 neutrons.
The symbol for zinc is Zn. Then look at the atomic number, which is 30. You'll fill it in at the bottom. And the atomic number is also our number of protons and our number of electrons. So you can fill that in. And then we have to find the atomic mass. The atomic mass is 65.39, so that would round to 65. You can write that down underneath the box. And then to figure out our number of neutrons, we'll use the mass rounded minus the atomic number. So 65 minus 30 gives us 35 neutrons.
Oh, yeah, that's about it.